Good morning, good afternoon, good evening, good whatever time it is, wherever you are in this amazing planet. I'm Malcolm. I'm your host for the CDO Matters podcast. And I'm also the CDO of Prophecy. We make MDM, Master Data Management Software. And if you've got questions about MDM, hit me up on LinkedIn. I will happily chat with you. Today, I am joined by Ron Green. Ron is the Chief Technology Officer of KungFu.AI. I just want to keep saying KungFu.AI over and over again. I love that. I love the name, KungFu.AI. You are, I would describe you as an AI services company. Is that fair description, Ron?
Yeah, that's exactly right. We are an AI strategy and engineering firm, and we help our clients with pretty much everything under the sun related to figuring out your AI strategy and building custom AI solutions.
So not only is Ron the CTO, but you are a co-founder, yes? And you started this in 2017. So this is before, the OpenAI firestorm. You saw the writing on the wall and started pretty early.
Yeah,
well, not really early, but generally early.
Yeah. I actually did a master's in artificial intelligence back in the late 90s. So, it's like one of those, quote, overnight successes that only took 25 years.
And so I'm glad we're going to talk today. We're going to talk today about AI adoption. We're going to talk about what Ron is hearing in the market, what companies are working on, what they're not working on. We're going to talk about the perception of data as an enabler or maybe a hindrance to some of those AI aspirations. We're going to talk about all things AI, the state of AI, through the lens of somebody that's out there helping customers build the stuff. Right, not through being in the data engineering, which so many of the people and listeners of this podcast are, but from the perspective of folks that are helping others and get enabled with AI. Ron and I actually have a little bit of a history. I'd met Ron, I want to say probably, my guess, Ron, would be 2018 when you, or maybe even before, I was working for the startup called Quick Arrow, which was an Austin Ventures startup. And I want to say we had a connection through AV. I can't remember what our connection was, but I'm pretty sure we had coffee in a Starbucks at Anderson Mill on 183 in Northwest Austin.
That's that totally rings a bell.
Yeah, I'm pretty sure we did. But then I know for sure that we had at least one meeting, maybe even more, when I was at Dun & Bradstreet up off of Palmer, and you were starting KungFu.AI, talking about, okay, how could we potentially work together? So I know that we had at least one meeting. This is a way of saying, friends, if you're listening to this and you're a younger professional, don't ever burn a bridge. don't ever burn your bridges, because you never know. 20 years later, you could be on a podcast with the person you burnt the bridge on. So, it's such a small world that we live in. It's such a small world.
It really is.
Anyway, Ron, let's talk about, let's first start with the kind of the general flavor. What are some of the projects that you're involved in that are really interesting, that are really challenging? What are some of the things that you were seeing in the market from the demand side around custom AI development? What are some of the trends?
Yeah, it has changed quite a bit, I would say, over the last 8 years. When we started KungFu.AI in 2017, if you were working with us, you were an early adopter. Like, you were a true believer. And so most of the clients that we worked with back then had sort of very specific problems they were trying to solve, and they knew that they were not addressable with traditional software approaches. So a lot of computer vision, natural language processing, that type of stuff. The biggest question back then was, was AI real? Like, could it actually solve these types of problems? And the amount of data you needed 8 years ago was considerably higher than you need now. So if we were doing a computer vision project, even in 2018, you weren't flat-footed from a modeling perspective. You could come in, you could use open source weights to kind of jumpstart the initiative. But on the natural language processing side, there was almost nothing. You were almost just starting from zero every time. That's completely changed across the board. So regardless of what you're doing now, you do have that head start. What's really changed, I kind of think there's been 3 phases over the last 10 years. There was the early adopter phase, and there was really narrow AI. We would build systems that could solve one problem. You could maybe solve it at a superhuman level, but it was very narrow. Then generative AI explosion took over, and there was I would say almost like an overcorrection. Everybody thought generative AI could solve any problem. and they were frequently really blind to the complexities of deploying generative solutions because they, like we were talking about before we started recording, these AI systems are probabilistic. It is very difficult to prevent generative systems from hallucinating and things like that. And that intense focus has really subsided. And I think we're entering a really strong phase where there's a balance. And where we're seeing our clients get by far the biggest return on their investments is when you leverage your company's proprietary data to build an AI capability that either automates some workflow that's really intensive. It's a predictive system that you've got this historical data and you can use it to identify outliers. And this can be used, in just countless ways. Or you're enabling some new entire capability within the product suite that you couldn't do before because we just didn't have those capacities within artificial intelligence. But the key point I'm making here is that it's having proprietary data where you'll see the bigger return on the investment. I definitely want to dig into that a little bit more because it's where we're encouraging our clients to look.
So before we dive into there, where are you seeing, from your client perspective, where are you seeing the demand come from? Is this CDOs who are recognizing, hey, I got the data, I just don't have the resource to do it? Or is it business function heads? Like, is this the head of marketing wanting to do a propensity model? Where are the demand for these solutions coming from your client base?
That's a really great question. It's changed. I would say in the beginning it was very, very, focused. It might be somebody in product or it might be somebody in IT. Last year, it was crazy. We would have people call us up and say, hey, can I have some AI? And we'd say, well, what do you need? And they would say, I don't know, but I need some AI and I need it fast because, the board is going to kill me. Now it is almost invariably C-suite driven, very often CEO driven, meaning there is a push to embrace AI, and the specific nature of that is sort of TBD, but we've got to get on board. And what's really exciting about that for somebody like me who's been doing this for so damn long is I would have conversations, Malcolm, like 4 years ago, they'd say, what's the difference between AI and crypto? Like, aren't they kind of both scams? And so, we're really in a place now where we don't have to convince our customers. And so we deal with everybody, the CMOs, CIOs, CTOs, product owners, CEOs. It's really across the board. We have people reaching out to us now.
Separate podcast maybe about the convergence of AI and blockchain. I think there could actually be something there from a blockchain perspective. Anyways, separate podcast, because I fell down the blockchain rabbit hole many years ago and have not managed my way to get out. But interesting. So when you say the CEO, does this then the CEO is driving and saying, get this done? And then is the CEO saying, hey, go talk to my CIO, go talk to my CDO, but just make this happen? So that's interesting. Are these folks, and I don't know, this may be too probing a question. Are you seeing a lot of people like, okay, heck yeah, let's go? Or is there reluctance? Do they feel like there's been a kind of a gun put to their head from an AI perspective? Are you talking to CIOs or CDOs that are saying, I don't know why my CEO is pushing me on this. I already got this figured out. We turned on Copilot last week, right? Is there any tension there that you encounter?
It's another great question. I would say a few years ago, yes, there was this sense of like, hey, we have ChatGPT, we're set. What else would we need? What's happening is, it's a really competitive market, in the world. And so as companies have sort of maybe sat on the sideline to wait and see what happens, and then their competitors release AI-driven capabilities, nothing will light a fire quite like that. And so we are now seeing, I would say, more than half our engagements are essentially a combination of strategy and engineering, where it's companies who don't know how to get started, they don't know how to maybe find the talent, they don't know how to vet the opportunities, they don't know necessarily how difficult it would be to execute. and how to truly estimate the ROI around them. And so they're looking for help on the strategy side, on the road mapping side, and on the execution side. And what we see a lot is that they'll come to the table with really good ideas, but there is maybe a misunderstanding on the data side. Data has always been important. It has never been more important. The dominant approach within artificial intelligence right now is this technique called supervised learning, where you build models and you train them on a bunch of example data. And the beautiful part about this is that these models can learn to generalize, and they can become really good. You almost can't overload them with data. They'll soak up all the data you give them. But the challenge is you have to have that data. So an example we'll see a lot is there will be maybe some very manual process that humans do. And maybe it is a sort of a decision process where there are many, many touch points and you want to automate that. And we'll engage with clients, and a lot of time they don't have the data. The humans have made the decision. They've taken in the input. They've built up heuristics and intuitions over many, many years, and they are making decisions. And then if we come in to automate something like that, and almost without exception, it's human augmentation. It's not replacing the human entirely. It's automating the more mundane aspects. But they haven't captured the data. So that means it's basically locked in the humans' heads. The good news is if this is a critical path initiative, it's better to find out now that you don't have the data so you can start collecting it than to find out 3 years from now. So often, bad news is good news in the long run. And then the other really big aspect on the proprietary data side is quality, as we were talking about. Just having garbage in, garbage out is probably never more true than for these supervised learning AI systems. You need high quality data. It doesn't mean that it has to be perfect. And it doesn't mean it has to be structured. That's one of the beautiful things, that you can just kind of dump a fire hose at it. But there are some minimum thresholds you need from a data distribution perspective for it to really deliver meaningful results.
Okay, so 3 things that we touched on around the data. One was, you had said earlier about the importance of having kind of proprietary data sets in order to do something really unique. Want to touch on that. The second thing you said is companies maybe not having the data. So they've decided from a strategy perspective, or just a kind of a fit from a use case perspective, or maybe it's a customer demand perspective, they decided on, I want to model XYZ, right? Like this decision process, maybe it's buying a pair of jeans or building a custom home, or who knows, right? But that for whatever reason, that company doesn't have the data. Like there's nothing to train on, because in your words, they've kind of relied on just gut, aka heuristics. I love data scientists, love fancy words for saying intuition.
Yeah.
Heuristics a form of intuition, but arguably an important evolutionary process that heuristics over time, but
Right.
less valuable in the data science world. The third thing that you touched on was the idea of data quality. Let's address those in reverse order. Let's come back to data quality. Now, you described the problems of data quality from the perspective of supervised learning, which is not generative AI, right? These machine learning tactics are not generative AI. Is it correct, Ron, to say that you could kind of divide the world into two? Now keep me honest here.
Yes.
Where one of these worlds is the kind of traditional machine learning, supervised reinforcement learning, world, and then there's the Gen AI world. Is that a heuristically true perspective?
Not really. I probably wouldn't
No.
divide it along
Okay.
those lines.
Okay.
Because even very large language models, for example, like ChatGPT and Claude, even though you wouldn't strictly say the training methodology was supervised learning, it would be semi-supervised with a sort of a reinforcement learning with human feedback, or something post pre-training regimen. And semi-supervised, what that really means is, people often talk about large language models were trained on the entire internet, right?
Yeah.
Well, there's no way people can label, all the input. Well, actually, the pre-training task is pretty simple. You just take corpus of documents, and there are training open source training examples out there that have billions of tokens, trillions of tokens, in fact, and you just simply put them in and you mask out future tokens. So I'll show you the first token or word, you have to guess the second one. I'll show you the first two, you have to guess the third one. You do that for the entire corpus. And you can do like intermediate masking and other things like that. But the important thing is, even though it's not pure supervised learning in the traditional sense, it's still mostly supervised, even if it's called semi-supervised. And
Oh, I see
so
what you mean.
the real difference between generative AI and non-generative AI is generative AI is designed to be able to generate new samples that mimic its data distribution, distribution it was trained on. So it can generate essentially from this sort of high dimensional manifold it learns. And in non-generative AI, they're either sort of classifiers, and they can be continuous or discrete, but they're predictive in some way very often.
I guess for me, I talked about this potential split because, as the data geek that I am, I look at things through the lens of structured data versus unstructured data. And structured data, from the view of the CDO, we know reasonably well because we've been doing classic analytics reports, dashboards, rows and columns. We've been doing that reasonably well for a while, and we've figured out processes and how to govern it. We've figured out processes and how to assess quality. We've figured out how to even do things like data validation, right? And saying, is this correct? Is Ron Green actually really Ron Green? We're reasonably good at that. The unstructured stuff, that's hard, right?
Right.
Data quality, at least from the perspective of data validation and verification, is something assertively true. Is it correct? When it comes to unstructured data, that's really hard. And I think that's what some of the data professionals I know are really struggling with, that because that world is so subjective, is so context driven, is so non-deterministic.
Right.
That's why I drew the distinction between Gen AI and other forms of AI. In that Gen AI seems to really like all of that text, and the other stuff that you're talking about can actually handle and is happy with rows and columns. Is that a more correct assessment?
I hate to say it, Malcolm, but no.
Damn.
The non-generative AI algorithms do really well on non-structured data as well. So, for example, images or
Yeah.
just plain text files, or rasterized content. I mean, just pretty much anything under the sun. The challenge we always had before was, it was kind of multifold. One was, you're dealing with discrete data types, and you need to have a way to represent them in a space that is continuous. Okay. And if there was anything anybody took away from this podcast that I would be delighted about, there's a concept called embedding. And it's essentially where you can learn a continuous representation of discrete inputs. So I can take a photo, and I can map it to some high dimensional space, and it's a point in that space. Or I could take a word and represent it on some complex multidimensional manifold. That is common to both of these, both dealing with structured data and unstructured data and generative and non-generative AI solutions. And to me, that's actually kind of one of the slept on breakthroughs of the 21st century. This idea that we can take discrete domains and manipulate them in these high dimensional continuous spaces. And the beautiful part, one of the reasons that we're seeing amazing sort of multimodal models now, like single models that understand audio and video and text, and can generate text and can generate images, et cetera, is because we have a unified architecture to represent these inputs in this combined embedding space. And to me, that's one of the, like, again, most critical breakthroughs of the 21st century.
So let's get a little more specific, and let's assume that I'm ignorant in this space, and I appear to be showing myself that I am. Let's talk a little bit more about this idea of an embedding. Let's start from the simple use case of I have a file of data related to customers, right? And I know how many goods I have got, this time series data or transactional data that shows customer bought X at this date and time and customer bought Y at this date and time, right? And I've got customer data sitting in relational data. This idea of an embedding, let's also say that I've got a big blob of text coming out of a CRM system that is just a salesperson is describing, or a customer service agent is describing a discussion that they had with that same customer, right? Maybe it's you. The embedded form of that text is, are you saying that that now these systems are basically able to say, okay, I can take customer out and I could vectorize that. I could embed that somehow in this array of numbers, and I can relate that customer interaction with this transaction in a relational table, with this transactional relational table, with a video of this person because it happened to be tagged with that person's name for whatever reason, that I can relate all those things together?
That's a perfect example. That's a perfect example, because essentially what you're doing is the embedding space that the model learns, you get to decide what it represents. And so with language models, when the tokens come in, the words come in, they've already been embedded. So they've already learned some embedding. And there's a concept that you can hold in your head, everybody listening, that I think is just beautiful, which is these are highly, highly multidimensional spaces. Well, that's just a fancy way of saying for every word, it's an array of floating point numbers that could be thousands of floating point numbers. But conceptually, that's just a point in some multidimensional space. And if we imagine embedding words in a three-dimensional space, then they could be, words here in our world that we could, we could see in 3 dimensions. And the beautiful part is this: the traditional approach is to have the semantic meaning of these words be represented in that embedding space. And so if you took a word, if I gave you a word like the word cat, and I located it in this 3-dimensional space, if I drew a sphere around that word, all of the words closest to it will semantically be similar to it. And so I would see, like, cat would be closer to lion than cat would be to bear, or something like that. And that's the beauty of this. And so, sticking with your customer data example, you could embed customers into a customer embedding space where they are grouped by buying behavior or buying propensity or style or knowledge we know about them. Maybe they're where they live, or, it's just an infinite number of things. And it's that trick, which is how you can do things like recommendation engines, or you can do fraud analysis, because you'll have these outliers that just stick out, or you can use it to do buying trend analysis, and, like you mentioned, time series and things like that. But it's all predicated on being able to take this discrete data, which again might be a photo, might be a paragraph describing an interaction, and mapping that into some embedding space that the AI model can operate on.
Well, it sounds a bit like a knowledge graph to me.
In some ways it is. And in fact, graph neural networks are becoming quite popular. And the difference between sort of a graph neural network and a traditional approach is it's called inductive bias, where you're essentially describing how closely related items are within that space, using sort of graph techniques. And maybe one of the best examples of that is with, like, protein fold prediction, where they know that there are relationships that are predicated on spatial proximity that need to be understood, and you can represent that with graph neural networks.
All right, very cool. So I want to skip the second question about the data not being there, because maybe we can end on that, because that's going to get into these like pithy comments related to synthetic data that my brain may or may not be ready to consume. But let's go back to the importance of this proprietary data and arguably monetizing or operationalizing this proprietary data for use in AI. Everything you just described, it sounds like that's what would necessarily need to go into a solution to make sure that maybe your foundational model, be it off the shelf or not, the foundational model that you're using could be, for lack of a better word, grounded. Is that the right way to describe?
Yeah,
You can control or optimize the behavior based on this unique data set that you've got. Is
yeah.
that prime? This is the work that you guys are doing day in, day out. Yes.
That's exactly right. And you would not necessarily need to start even with the foundational model. I'll give an example that I think will maybe clarify. One of the projects we did last year worked with a publicly traded company that does loan factoring. That's essentially buying. This is within the trucking space. Truckers will deliver a load. Maybe they drive from Los Angeles to New York. They deliver a load. They won't get paid for maybe net 30. So they can sell that invoice, get paid now, and then the company takes, like maybe 1%. There's a lot of fraud in this space. This company's doing, I think it's 2.6 billion in loans per year, and the average loan amount is $600. So an enormous amount of volume, just an enormous amount of volume. They have hundreds and hundreds of people validating every day the paperwork. And they had built up a proprietary record set of transactions going back 20 years. And they were interested, hey, is there a way where we could automate some of this decisioning? And it took about a year, but we built a system that, and I just love this. It took the loan decisioning process down from 24 hours to 9 seconds. They moved from only operating during business hours to around the clock 24/7. So, if a trucker needed to get, an invoice bought on Christmas Eve, that's fine, they're open. Fraud levels dropped, chargeback levels dropped. And the beautiful thing is we designed the system purposely so that it was human augmentative. All of those 100 people are still there because they were able to essentially change their business stance and increase the volume that they can deal with. The humans now handle about 40% of the cases that the AI says there's something wrong here. Either the paperwork's incorrect or there's something it's suspecting might be fraud. And the humans can get, they can get on the phone and they can call people and actually reach out. And the beautiful part about this is this system was built on all of that proprietary data that none of their competitors have, and it's wrapped with the policy shell. So the model, as you mentioned earlier, it's probabilistic. It's making probabilistic decisions about the likelihood of repayment. And then based upon the model's confidence, it goes through a series of sort of human crafted policies that ultimately decide if that loan will be approved automatically. And here's the beautiful part about all this. This new capability instantly resulted in $250 million market cap bump when they announced it last October, because it's going to transform the
regardless of whatever the actual business returns were. You're talking about a market cap return just because they announced it to the market.
That's right. Because they were able to announce that they are going to 24/7 and customer leading behavior. They were already the best in the business at 24-hour turnaround. Now it's 9-second, and incidentally, fraud and chargebacks are down. It's just one of those wins. And so we are always preaching to our clients, don't go build something that is based upon open data that any of your competitors could duplicate. Or don't go put a bunch of time and money in building something that doesn't give you market competitive differentiation. The golden standard, and this is just one example that I mentioned, is take the legacy proprietary data that you've built up, and to your point about unstructured data, a lot of times they don't even realize that all that unstructured data is just gold, just sitting there waiting to be leveraged. And if you can build new capabilities or predictive systems or whatever it may be based upon your proprietary data, the return of that investment, it will just be astounding.
All right. So, so much for there being no business case for investments in AI. I mean, if I had $1 for every time that I've heard that over the last year and a half, I'm like, I don't understand it. Like, even if we're just talking about Gen AI stuff, I went to Gartner Summit earlier this year, and that I would say that was perhaps one of the prevailing winds that I was hearing was this idea that, productivity on the desktop, nah, not really. But when we start to change business processes, that's when the money's really going to flow. I don't know an engineering organization that isn't 20 to 30% more productive from using copilots. I don't get this. I don't understand this.
I don't understand. I don't understand it either. I do a lot of public speaking, and I'll ask people, raise your hand if if you're using AI daily, and it's like, 95%. Then I'll say, raise your hand. You keep your hand up, or raise your hand if you just don't use AI at all. And there's always just a handful of people, and they're like, I'm not impressed. I don't get it. It is transforming the way we work. We're an AI company. We're leveraging AI coding assistant tools like crazy. We use it for data analysis, the deep research capabilities. I mean, to me, it's analogous of people, in like 1999 saying, the internet, that's not really going to affect my business.
Who's going to buy clothing online?
Exactly.
Right? Like, I remember that. Like, they may buy a book, sure, but they'll never buy clothing online. They'll never buy like durable goods online.
I literally had somebody tell me one time, I remember it was in the early 2000s, and they said something like, I would never give my credit card out on the internet. They're just mind shifts. It's technology. I think a lot of people, and probably a lot of people listening to this podcast, we like technology. We kind of embrace change. There's a large segment of the population out there that is fine. They would wish that their user interfaces never shifted, never changed. Just keep it as I know how to use it now. The change is not something they're happy about.
Well, I would argue if you are one of those folks, if you are a more of a late adopter, and that's okay, and that's fine, but your business needs you to be an early adopter, needs you to start taking more of these risks. And if you don't, maybe your CEO is just going to make you do it.
I think that's true. I think that's exactly true.
Yeah, or you'll get reorged under the CFO, or you get reorged under the CTO.
It's that old saying. It's like AI is not going to take your job, if somebody using AI is going to take your job. And exactly. I think there's a lot of truth into that saying.
So let's get back to some of these engagements that you're seeing. Right, one of the prevailing winds, above the fact that I'm hearing, people yell at clouds related to the productivity levels, and they're not really real, which I just cannot believe. Another one a thing that we hear often in the world of data is, there's so many of these POCs, and most of these POCs are just flailing and are not working, and that's a real problem. Yes. I'm not convinced it's a problem. I think if you look at data science as an inherently R&D function, a 30% success rate, you could argue, is reasonably pretty good. What do you think? Do you see failed POCs as a problem? Are you seeing a lot of that with your clients? What's some of the temperature out there in regards to this?
It's another great question. We really pride ourselves on getting things into production. No joke, when we started the company, I was like, I'm not doing AI POCs. I am not interested in science projects. And we staffed accordingly. The stuff we build works and it goes into production. That said, we will often have to go through a POC phase. And the reason is we don't know necessarily beforehand if the data is from a quantity perspective is sufficient. And, I think a lot of companies, if you understand, and I have a couple of thoughts here, like if you understand that AI systems are more complicated to build, they're probabilistic, that there will be challenges that are very organic in nature. Like, for example, you know, famously, you can have a computer program and you have a one letter typo and the whole thing breaks. Well, AI doesn't work like that. You could, take out 20% of the neurons and it will degrade in sort of a way like biological systems degrade, right? So it has a lot of redundancy, but unfortunately, it also has some of the negative sides of biological systems where it's more probabilistic. So if you come in and you've got a mindset, we're going to do some work, these POCs may not get into production, but we're going to learn and we're going to understand where our opportunities are. Great. What we often see is people come to us saying, we tried to build something and it didn't work, and we don't know why we got stuck. And the number one thing we see is this: they'll do some type of prototype, some POC. They'll get to like 75% accuracy pretty quickly. And they're like, oh, we're 75% of the way there. No, it is just incredibly difficult to ink out those additional percentages in performance. It's very much like semiconductor chip design. They'll drive it to like 98, 99% efficiency from a yield perspective, but to try to get it to 100 might double the investment, right?
Yeah,
It might cost you
it's not
$3 billion.
linear, it's logarithmic. Yeah, these improvements
Exactly.
are on a log scale. Yeah.
And so that's the number one cause behind these POC failures is, you can get to 60, 70% like that, and then you get stuck. And the sad truth is these are complicated systems. They're black boxes in a way. We're professionals, even we get stuck sometimes building them, and we'll go into hyper parameter tuning phases. And sometimes you're just like, why won't the model learn? It's just stuck, it plateaued. And then you realize, well, we need to maybe change our loss function, or maybe change the way we're initializing the weights, or do cold restarts and things like that. And it's almost sometimes you feel like you're dealing with the biological system. So again, I think it's totally normal that a lot of these POCs don't work. And if you have the mindset that you're going to learn from them, great. But most companies think, hey, we're going to go do AI and our first try is going to be a success.
So these are inherently iterative enterprises.
Really are. Really are.
Well, and so this would suggest that the traditional, or maybe not, that the kind of more traditional approaches from a software development perspective may not be a great fit here.
I think that's true. That's really true. Our methodology, which I'll share with the world really quickly, is start with EDA, exploration and data analysis. Do not start building models. Go look at the data. Go understand the signal. Go figure out. You may have thousands of columns of data, let's say, and let's say you're trying to build some type of like recommendation prediction system. Most of the signal might be coming from 3 or 4 or 5 of those columns. You might not need the bulk of that data. Only once you understand your data, then should you start prototyping. And it's very iterative. It is, even agile methodologies will sometimes fall down because it will be like, well, we're going to achieve goal X in this next sprint. Well, guess what? These things are black boxes. Sometimes you will get stuck and you have no idea what to do, and you're just iterating. I mean, my God, look, Meta just released Llama 4 a couple months ago, and by all accounts, they had a bad training run, and they wasted billions of dollars on this model that just didn't come out correctly because it is so complicated.
All right. I love the advice of understand what you've got, but I would argue, obviously, that what you described earlier as the kind of the strategy part of all of this, understanding the problem you're trying to solve, understanding the use case, understanding the desired outcome of the model is the place to start. Then kind of discover and probe your data to see what's needed and what's not needed. This is advice that I'm always giving on this podcast, which is don't just start from greenfield. Hey, we've got a lot of data. Let's go figure it out. Understand the problem you're trying to solve first and work your way backwards from there. That's a universal truth that we see, I think, with everything. Okay, it's a good starting point. You'd mentioned earlier about the data not being there, and I made this pithy comment about synthetic data, But I've heard that being tossed around a lot in that, okay, if we don't have the data, we can just create a lot of this synthetic data and this will solve a lot of the world's problems. It'll solve problems related to PII. It'll solve problems related to data availability. Is that where does synthetic data fit in all of this? And are people kind of over romanticizing its capabilities?
Oh, that is a tough question because I think it's really context dependent. We've done
Okay.
projects where we've used synthetic data, and it's really most frequently needed in situations where you have a really skewed data distribution. So, for example, you are trying to fraud's a very common example. You're trying to predict fraud. Well, guess what? It's a good thing. Fraud's kind of rare. It's like cancer. It's kind of rare, which means almost by definition, you have a data distribution that is not going to lend itself to training a fraud detection model because the vast majority of the data you have is the non-fraud case, right? And that's the whole reason you're building the fraud detector in the first place is that it's hard to detect, it's rare, etc. So synthetic data generation can happen, but if there's a little bit of a chicken and an egg problem there, for you to be able to synthesize new data that correctly sort of mirrors the real world but missing data distribution, you kind of have to have enough data in the first place to bootstrap yourself. So I do think synthetic data and other training techniques like that really have a big role to play and a meaningful role to play. But it's not a magic bullet. You can't go into a situation. We were talking earlier about the experts. Hey, we have all these experts. I would like to be able to have a system replicate their predictive capability. And I say, okay, well, where's the training data? And you say, well, it's in their brain. Synthetic data generation is not going to help you there.
Awesome. Well, that's good news. I'm glad to hear that. You can't just create data out of thin air if you don't have any data at all. You can't just synthesize it,
Right.
magic wandy. It still needs to be there and in a meaningful way. All right, last question. A big topic for data people like myself when it comes to AI is this idea of making your data AI ready. You've talked a lot about the importance of data, having the data. You've talked a bit about data quality. Maybe that's the answer that you're about to give here. But to you, somebody that's out there building these, so a data scientist, somebody's building these solutions day in, day out, every day. What does AI ready data mean to you? And how do you recommend that CDOs do a better job at making it?
Tough one. I don't think there's any blanket answer I can give that will apply to every situation, but there are general sort of best practices. One is having your data siloed and distributed in ways that make accessing it difficult is a frequent bottleneck. That is a challenge. Having data that has semantic changes over time, meaning we'll see this a lot. Well, this column used to mean this, but prior to 2012, it means this other thing. So unifying your dictionaries, your data dictionaries, for lack of a better term, and making sure you have consistent semantics, really, really important. Dealing with bias and understanding that and realizing, like, one of the top misconsiderations is that you'll build these AI systems and they will understand what's important, or they won't be biased, and they'll have this sort of omniscient capability to disregard unimportant data. No, they will suck up and memorize anything you give them. So if you have a data set and it has biases in it of any type, that model will replicate it. And so, for example, let's stick with the loan example we were talking about earlier. If you build a system and it's got biases in its loan behaviors, but you act like it doesn't, you're like, oh, this is an omniscient model, it's always making the right decision. You're fooling yourself. So basically the answer is, consolidated, consistent data is great, but I would highly not recommend people go do a bunch of work on their data in the abstract, sort of in a vacuum to get ready for AI. Make it initiative driven, and you'll probably have a lot less wasted time and a lot less heartache.
Oh, that is pure gold right there, right? Because I think that's one of the struggles that data people have, which is this nebulous, platitudinous nature of the statement of get AI ready. That sounds like I need to clean the entire house, and I'm not even entirely sure where to start.
Right.
And what if my guests are staying in the bedroom and not in the guest room, right? Like, I don't think I need to clean the entire house, and I
That's
don't think
right.
you do either. This and I said last question, I was lying. But something that was you just talked about from a bias perspective, and one of the things that I kind of struggle with is not necessarily just relevant to bias, but this idea of data quality as a reflection of the way that the world is, or the way that we want the world to be.
Mhm.
Is it both in your world? Is it necessarily both, or is it just strictly on the behavior that you want of the model itself? Right? Is the only way that this is another way of saying is the only way that we can really assess the data quality through the performance of the model, or can we assess the data quality in advance of the having the model defined, just in some sort of abstract, deterministic terms of okay, it's good or it's bad?
Yeah, you
See what
can
I'm trying to get at
definitely,
here?
yes, you can absolutely analyze the data in isolation prior to doing any type of
Okay.
modeling. That's entirely possible. One of the weird things, though, that I just can't help but comment on is your models are always going to be biased in some,
Right.
just in the same way that humans are. You just have to decide what that bias is, right? And that's one of the challenges I think we're all going to experience with the introduction of artificial general intelligence is these are not going to be omniscient, omnipotent systems. They're going to be incredibly intelligent, maybe even superhuman intelligent, but they're going to come to the table with biases in one form or another because that's the nature of the universe. And so, again, understand your domain, understand your data. You can do bias analysis in isolation, but it's a business decision ultimately. What do you want? And that will drive how you manipulate the data and clean and debias it, or whatever it may be. And it will help you on the modeling side because you will have to make decisions on the modeling side that are, tangible everyday decisions about confidence levels and things like that that only humans that understand the nitty-gritty details will be informed to make. The model can't do it themselves.
Not to mention just an overall kind of risk assessment. Like, what are we ready to accept and what are we not ready to accept? And
Yes.
that's going to vary by use case. And I'm not even entirely sure from a governance perspective, we know how to assess quality today. We know how to wrangle, we know how to do ETL, we know how to help with some of the semantic consistency issues that you're talking about. But the overall risk assessment from a business perspective, and are we ready to do this? Is it 90% or is it 95%? These are some questions I'm not entirely sure that we've done a lot of asking historically
Mhm.
because we really haven't had to, per
I
se.
agree.
Yeah.
I totally agree.
All right. Fascinating conversation. We could keep going for hours. Ron, thank you so much for coming on the podcast, sharing all of your wisdom, helping educate me about some of the fallacies that I had long embraced around the differences between forms of AI. Really, thank you so much for your time.
Malcolm, thank you so much. This was a blast.
Hey, what's a good way to get in touch with you, or to learn more about KungFu.AI? What's a good follow
Yeah,
up here?
you can hit our website, KungFu.AI. You can email me at ron, at KungFu.AI. And if you want, sort of a deeper technical dive, we have a podcast called Hidden Layers. Check that out. We cover sort of the latest breaking news in AI every month.
Awesome. Sounds like a podcast that I need to subscribe to. All right, Ron, thank you again so much. And for our listeners, thank you for subscribing. Thank you for checking us out week after week after week. Hey, I've got to say, if you haven't already got one, pick up a copy of my book, The Data Hero Playbook. It talks about the mindsets that we need to embrace in order to embrace this AI-enabled future state. It's all about mindset. Ron, thanks again, and thanks to our listeners. We will see you on another episode of CDO Matters sometime very soon. Bye for now.